Okay, in this video we're just going to run through a few examples of clarifying how we find vertical asymptotes, and then also being a little bit more specific and knowing how we show good work for describing what's going on either side of that vertical asymptote. So we've looked at something like part A before. Maybe one thing that would be helpful is just factoring it apart a little bit. So the numerator can be x plus 1 times an x minus 1. The denominator I could factor out a 2 and I would get, let's see, x plus 2 left behind. So it's pretty obvious for us now that we see that there are x-intercepts at -1, at +1, and then a vertical asymptote at -2. What we're trying to do, so maybe we should write that down a second, is that we do know there's a vertical asymptote at x equals -2. That was part of the instructions. Okay, but now we want to describe the behavior on either side. For that, I'm just going to suggest that we go back to our friend, a sign chart. But we don't need to do all of the work that we typically did with a sign chart. So we would mark in a -2, we would mark in a -1, and we would mark in a +1. But all I'm really worried about is what's going on at -2. I know it's got to be a vertical asymptote, so whatever sign, positive or negative I get, that's going to tell me that the behavior on that side is going to tell me if it's going to trend up or trend down. So maybe maybe I'd start with thinking about what's going on. Maybe I plug in a -3. If I plug a -3 into all three chunks of my factored part, I get negatives for all of them. So I get a negative here, a negative in the second chunk, and the whole denominator would also be negative. Okay, so overall that means that this chunk is going to be negative. It's going to be going down. And then the next chunk might be a little bit more difficult because there's not a whole lot of numbers within there, but just pick -1.5. If I were to do that, my first two chunks in the numerator are both negative, but if you think about it, my denominator would be positive. So that means this is going to be positive. Okay, so if we write out our formal sort of answer here, we would say that the limit as x approaches, let's see, we're looking at -2, and we'll start from the right side of this function. So we need to say of function f of x, we need to say, well, what's that going to equal? So again, we're not doing this on a graph, we'll just do it on our sign chart. But as we come from the right side, especially starting around -1, what we notice is that there's got to be a vertical asymptote right there, and it's positive, so it's going up. Okay, so my answer for this would be infinity. And then if you've kind of put the pieces together there, then if we do it from the left side, so we have that little negative symbol there, that's in the negative chunk, so that's going to be going down to negative infinity. That's kind of the idea there. Okay, this chunk, it's got a little bit more to it, and I'll show you why in just a second. We may not do the entire thing in this one, but maybe we'll leave it up to you to kind of finalize your answer. But again, if I want to break this apart, my numerator is kind of already broken up, so I'll just leave it as 1 minus x. My denominator is a little bit more complicated, so I'm going to have a 2x for one chunk, and then just an x for the other chunk. They need to multiply. These two numbers I'm picking, they need to multiply to a -3, but then the O and the I of FOIL would have to add up to a -5x. You could ponder that for a little bit, but I think if I put a +1 right there and a -3 right there, that seems to work. So that means that we would have vertical asymptotes at -1/2 and +3. So again, we could go about making a sign chart for this. Okay, we have an x-intercept at 1, so we don't want to forget that. But we'd be at -1/2. We'd mark +1 down, and then we would also mark down 3. This one's a little bit more complicated because I need to check around 2 vertical asymptotes, so there's a whole lot more writing that's involved. So that's why I'm probably not going to write everything out here. It just takes a little while, but I might ask you a couple questions based on the sign chart that we come up with here in just a second. So let's go through and plug in some of our values here. Maybe I would start by plugging in maybe a -1 or a -2 way on the left side. Okay, and when I do that, I'm going to have positive in the numerator, and then I would have, let's see, 2 negatives in the denominator. So altogether that would be a positive chunk there. Okay, and then to the right of that, so I could pick 0 for that, I'd have positive in my numerator again. And I would have positive for the first chunk there and negative for the second chunk, so overall that would be negative. Then maybe I pick so let's pause there for a second. Now I know what's going on to the left and the right of that vertical asymptote. So that's kind of one chunk of the problem, and I want you to think visually what that might mean and just be prepared to answer a question about that here in just a second. But let's finish up the question here first. Maybe I plug in a 2 now. If I plug in a 2, my numerator now is negative. And the first chunk here would be positive, and my second chunk is negative. So altogether that is a positive chunk. And then put in a 4 perhaps, numerator is still negative. And the bottom parts would both be positive. So these will be overall negative. Okay, so now you have enough info to kind of answer what's going on right around x equals 3. So I want you to think about that. This is a little bit of a longer process to write this out, but I still think you should be able to do that if that was asked of you. Okay, then our last question here. This one's, again, I think a little bit easier to work with. If we were to factor this apart first, okay, the numerator already is nicely done, x minus 2. Okay, my denominator, I'd have 3x in one chunk and an x in the other chunk. I had to think about how these numbers are going to come together, but I would have a plus 1 right there and a minus 2 for this one. So notice we have a hole at x equals 2. Okay, so really what I'm left with is 1 over 3x plus 1. So that means I have a vertical asymptote at x equals negative 1/3. Okay, we go to our number line. And so again, we just kind of quick check a couple things. My numerator here is going to be positive. Always positive, right? If I plug in, let's say, like a negative 1 or a negative 2, my whole denominator would be negative. So overall, that's a negative chunk. And over at 0, perhaps, I'd have positive in the top again and positive in the bottom. And I suppose if we really thought about it, we probably understand that 1 over 3x plus 1 is somehow related to that reciprocal function, that hyperbola sort of idea. So some of this we probably wouldn't even need to show. But at this point we have enough to, again, write out our answer. We'd say the limit as x approaches negative 1/3, we'll go from the positive side first, of our function f of x. Okay, that's going to equal infinity because we're coming from the right side. And then the limit as x approaches negative 1/3, but now from the negative sign of this function, that's negative now, so that's going to be negative infinity. So a couple of examples there just to walk through kind of the correct notation. This is a bit of a longer process, but still I think this is probably an easier way of figuring this out than having to go through and trying to graph the entire thing.